This video is part 3 of negative indices, and we're going on to, I'd say, probably the hardest types of questions you can expect, and this would be where we have fractions that contain negative indices. They're actually not as bad as you think. So let's have a look at the long way. This is the long method and not the way I recommend you doing it, but I think it's important to understand the long way to get a quicker way. So you can't really use quick methods, I don't think, if you don't understand where they come from. So in our last video, we talked about how if you have b to the minus 3, I could write that as 1 over b cubed. So all I've done at this point in time is I've changed this expression in the numerator to an equivalent expression. And what we'll now do is go back to year 7 fractions, where we know that if you are dividing, so this really means 1 divided by 1 on b cubed, that bar there can also be changed to a division sign. If I have 1 divided by 1 on b cubed, that's the same as we keep the first expression the same, we change the division sign to a multiplication, and then we take the reciprocal, or we flip the second fraction. So that would become just b cubed on 1, which is just b cubed. So what I want you to notice is we've taken all those lines to go from 1 over b to the minus 3, just to get b cubed, and I'm wondering if you can note if you can see anything interesting that's happening. We're going to do that process again with a slightly more complex expression. This time around we've got a to the minus 2 over c to the minus 7. So a to the minus 2, I can write that as 1 on a squared, and c to the minus 7, I can write that as 1 on c to the power of 7. And we know that when we are dividing fractions, we will keep the first fraction the same, change the division to a times, and flip the second fraction. And when we multiply horizontally, c to the power of 7 times 1 gives me just c to the power of 7, and a squared times 1 is just a squared. So this time around we're going from this expression to this expression, and I'm wondering if you can notice what's happening again. The same thing's happened in both questions, where we go from the a to the minus 2 in the numerator moving to the denominator, and the c to the power of 7 in the denominator then going over here to the numerator. But we've lost our negative powers with both. And even here we had a b to the minus 3, and it has travelled to the numerator because we could write this as over 1, but we don't need to. So the b cubed has gone from being in the denominator to being in the numerator. So we can actually express that instead of doing 1, 2, 3 steps of working. I like to change that into a rule. So we could say that if you've got an expression raised to a negative power in the denominator, we could write that as a to the n, so it'll travel up to the numerator. I just think of it as switching floors of the house. And if we've got an expression on the top floor, then it will move to the bottom floor as an x squared, and if an expression's in the bottom floor, then it's going to move to the top floor, but they must lose their negative powers. Alright, now this is a bit funny. Forgot to move these expressions, so I am going to just pause the video. Alright, let's have a look at these two questions. So using this little rule that we've just come up with, this rule, I want you to pay attention to the fact that it's applying to expressions with a negative power. It's not just any expression with an index, but expressions with a negative power. So it's going to be relevant really only to this term in this expression. So the question, if I had this on an exam, it would say simplify, because I can actually simplify both of these two expressions that I've given you. So this q to the minus 2 would travel to the numerator, and a long way to think about it would be that I'd have a q cubed and a q squared, because remember it needs to lose its negative power. The 8 doesn't have a negative power, so it's going to stay put exactly where it is. And then you really should see, or should hopefully notice, that these two can be combined because we're multiplying to q to the power of 5, so we'll add the powers all over 8. Same thing here. This rule that we've put inside this box here really only applies to the x to the minus 1 and y to the minus 1, only two expressions with a negative power. So the x will travel to the denominator. So we're going to have an x, which is already there, and we're going to have another x to the power of 1, and this y to the minus 1 is going to travel up to the numerator with the y to the power of 4. And when we multiply, because don't forget these terms are all joined by multiplication, we will get y to the power of 5 all over x squared. Alright, so let's have a look at when we get to probably our most complex kind of expression, maybe something like this, quite a little bit tricky, but not once you know what to do. We need to understand what it means to raise any fraction to the power of negative 1. So what I'm going to do now is we're going to look at a long method, the longer method, which is not the method we'll end up using, but it just makes sure you understand the processes. If I raise anything to the power of negative 1, for example, if I have a to the minus 1, that would be the same as 1 over a to the power of 1. So I'm going to drag this base of 2/3 into the denominator, and I will change its power to 1 now. But really, I don't really need to write a power of 1, so I don't need any of that. And then we're going to go back to using our knowledge of fractions from year 7. 1 divided by 2/3, that's the same as multiplying by 3 on 2, and that gives me a fraction of 3 on 2. So what I'm hoping you'll notice is when we raise a fraction to the power of negative 1, really what we end up with is the reciprocal of that fraction. And a reciprocal just means to take your numerator and your denominator and interchange them. So they move stories of the house. The 3 goes to the top story and the 2 goes to the bottom story. So how will I use that with a question like this? Well, what I will do is I would write that as m on n to the power of minus 1. And don't forget, you can have more than one power, where we're really going to be using right now this concept that if you have a squared cubed, you would multiply the powers. So really what I want to think about is what number do I need to put over here so that I keep the minus 4. And I really need a 4, because 4 times minus 1 gives me minus 4. So I haven't actually changed anything in the question here. So what I'm going to do is break up my power, but I always want the minus 1 to go inside. And the reason why I want the minus 1 inside is because now I know when you raise a fraction to the power of negative 1, it just means that you take the reciprocal of the fraction. And then from there, all I have to do is raise the fraction to the power of 4. So what I'm doing is I'm raising the fraction to minus 1 first, and then secondly, I'll raise the fraction to the power of 4. And raising a fraction to the power of 4 is fairly easy. We raise the numerator to the power of 4. We raise the denominator to the power of 4. Here we've got another example, and this is probably the hardest kind of question. What I want you to do first, before we do anything else, is just see if you can tidy inside this expression. Always look inside your bracket. With this example over here, there was really nothing to tidy, but really you should be having a look and going, can I tidy this up? And there is quite a bit to tidy, because I've got some negative powers in the denominator that can move to the numerator, and a negative power in the numerator that will move to the denominator. So let's move the z to the 4 up. Let's move the x down, and then I'm going to do exactly what I did in this middle example over here. I'm going to change this expression to a power of minus 1, and then I'm going to cube it. And when we raise a fraction to the power of negative 1, we can take the reciprocal. So let's interchange the numerator and denominator, and then let's just cube everything. So x to the power of 3 is x cubed. 3 to the power of 3 is 27. Don't forget, every single term inside that bracket needs to be raised to the power of 3. So every part, so that means the x, let's use all my nice colours, the 3, the z to the 4, and the y. So we'll do them all one by one. So 3 cubed was 27. Z to the 4 to the power of 3 is z to the 12 by multiplying the powers. And y cubed, or y to the power of 1 cubed, is just y cubed. And that is the end of that question. All right, I hope this helps you to handle some of those tough questions in my notes. Replay the video if you need to. Send me an email if you're still stuck.